All right, well, that's annoying because I recorded this entire thing without my mic on. So now we'll do it again. All right, here we go. We're going to name and classify angles. Woohoo! And we are going to measure and construct angles. We're actually not going to measure today just because we don't have the device yet, but I'll get that out to you. But we are going to kind of talk about angle measures and bisectors and how you can do it algebraically. So, measuring and constructing angles. Here's our vocabulary that if we don't go through enough in the notes is something that you'll want to reference, but we will get back to that. So, the first thing here is the interior of an angle. So if we're talking about an angle, we've got sides of our angle, which are rays. So it's kind of a key point here. And then the interior is all of this in here. Potentially what we're talking about is the fact that this is a part of a circle. So if we imagine a circle kind of going around with these dots, you're talking about this being the center and this just being part of that if you have referenced a circle graph before, something like that. So that's your interior angle. All right, so on the inside is that yellow part, and then we've also got our exterior angle, which is the outside, all of the points that are outside, so lots of them out here. We never actually talk about the measure of the exterior angle. It's a very rare occasion because all you need to do to get the exterior measure is to take 360 minus the interior. Because every circle has 360 degrees. If we subtract the interior angle, then we'll get the exterior angle. So anytime that you are hearing a measurement of an angle, it's usually the smaller or interior part there. All right. The next piece here is an issue because the program that I loaded from doesn't apparently love this symbol. So there should be an angle symbol here. Some of you may think it's a less than symbol, but it's actually more of like an L that's leaning, okay? Either way, if you do it one of these two ways, I don't know that in the long run it's going to affect much. But the idea is that this symbol here should have been in these boxes. So there you go. All right. As we look at this, turns out you can name an angle quite a few ways, just like a line. You can do it forwards or backwards or with a lowercase letter. In this case, you're actually looking at what we call the vertex. So this vertex here is kind of that middle of the angle, okay, or where the middle of that circle would be. And so that letter that's there, which is R, is very important. And so we could actually name this angle R. Okay. We could also name the angle SRT if you're following along this ray to the vertex and then along the other ray. And then, of course, if you want to go backwards, you can do TRS, so that's this next one here. And then we also have angle 1, because potentially having all of these letters might actually be a little bit confusing. So if you have multiple angles, sometimes there's a number inside. This number, of course, does not represent that this is like 1 degree, okay? I mean, it might be 1 degree, but clearly not in this picture. So the idea is that it's just an easier way to reference angles, or quicker. All right, so we do not want to name an angle just by its vertex, so this one option here. If it is if the point is the vertex of more than one angle. So let's say that you had a bunch of angles kind of meeting inside. All right, if this was the letter R for those angles, you would have all of these angles that actually have that R, and so it's very hard to reference which of them you are talking about. So again, we do not want to name just by its vertex if there's multiple. Okay, but if there's just one sitting there, which will happen, you can always just name it with one letter. So other than that, you would want to just stick to those 3 points to kind of be as specific as possible. All right, next piece here are types of angles, which I hope you are slightly familiar with. Hopefully you've heard the word acute angle, okay? An acute angle is always between 0 and 90. 90 is kind of one of those cutoff points, because then you have a right angle at 90 degrees. All right, after that you have something called an obtuse angle. Yes, it does have to do with that prefix there of ob, which would mean larger. Okay, so obtuse. And then we also have a straight angle, which is just a line, but of course it does actually have a measurement. So there's 180 degrees on every line, in case you're not aware. All right. So again, each of these names is based on how many degrees the angle that it forms makes. So this piece here is actually going to be given to you later because you would need a protractor for it. A protractor is a measuring device for angles. Kind of looks like a taco, anyway, a half circle. It's got little doodads all along here to measure. Okay, we don't actually have one of those right now. I mean, you might have one. Cool. But we're going to skip this part of this until you get one. I am going to send it to you, or you're going to pick it up. So anyway, we will skip that until next time. All right, so then we get to talk about congruent angles. Hopefully from the last set of notes you remember that congruent means that we're talking about something being the same. This is your congruent symbol, but we are also talking about things being the same image or the same size or measurement. So congruent angles are angles that have the same measure. In the diagram, again, we're supposed to have an angle symbol here. This is read as the measure of angle ABC is equal to the measure of angle DEF. So because of that, you can write that angle ABC is congruent to angle DEF. And again, right here, it says how you were supposed to read it, okay? Because if this was just written in a book, you would not necessarily know how to say it. So, again, on that note, angle ABC is congruent to angle DEF. If you're reading this phrase right here, notice there's these little M's. M is for measure. And so when we are talking about the length of, the measurement of an angle, we are talking about a number, okay, that it would be. Versus if we're just talking about an angle in general, it's your shape, and that is going to be congruent. So, again, we read this as the measurement of whatever ABC is must be the same as the measurement of whatever DEF is. Another way other than stating it in a statement here is with arc marks. So notice down here we've got these two red arc marks. Let's say that we have more than one set of angles. You can actually have more than one set of arcs. So if you want to say the two arc marked angle are congruent. You could also, other than one arc mark, you can put tick marks on the arc. So you could say this one and this one are the same. Or if you have multiple, you could do two tick marks. Kind of hard on that small picture, but there it is. And again, those are used to show that they are congruent or the same measure. There's also an angle postulate theorem, which we're going to go through on the next slide. But remember, angle addition is very similar to segment addition, and hopefully you remember that segment addition said, guess what, you can add segment lengths together. So this one is, guess what, you can add angle lengths together. The interesting part about a segment addition as well as angle addition is that they do have to share that coordinate. So notice that they're sharing that vertex. And so in this case, the shared vertex of Q will allow us to have angle addition. Otherwise, it's kind of hard to add angles that aren't necessarily coming together, because how would you know what they sum to be? So in this case, notice the blue angle is going to be added to the red angle, and then it's going to actually equal the entire angle measure. All right. This is where you hopefully will notice that we have our names as all three letters, okay? Because we cannot say the measure of angle Q plus the measure of angle Q equals the measure of angle Q, because that really doesn't make sense at all. If you have two of the same thing, how can it equal one of that thing? So definitely need our letters there so that we can say, hey, PQS, which is that up left angle, versus SQR, which is just that right piece, equals the entire thing, which is PQR. So again, you do need each of those pieces, otherwise that's not going to work so well. All right. So we're going to do an example after this definition about how we put those together. But before we get there, we're going to talk about bisect. Okay, and so we did do a segment being bisected, which meant it was cut in half. So guess what? This one's going to be two congruent angles as well, or half. All right. This ray here could also be a line, so you could have this angle cut by a line as well. You could also have it cut by a segment. Not sure where I got off on here, but the segment could also cut this angle in half as well as the line. So that's kind of why I'm adding those in there. Other than that, again, we're missing this angle image. So JK, this ray here, is bisecting the entire angle, which would be J in the middle here of LJM. And then that means that LJK, which is on top here, is congruent to KJM, which is on bottom here. And you can see in this case that not coloring it in like that, as they have with the green there, makes it a lot easier with the tick marks to see that I'm talking about this set of rays. Because depending on what's going on, there may be a very elaborate picture here. So that's your angle bisectors. This is annoying because the answer's right here, but the idea is that we're going to do this example, and it's telling us that the measure of one of our angles is equal to 2x minus 5. So that's kind of annoying because mostly we're thinking, oh, 33 degrees or something like that. But because we're trying to practice our algebra so we don't lose it on our way to Algebra 2, this is actually the measure. So it's going to be an entire expression there. So WYZ is over here. From W to Y to Z, you're going to get 2x minus 5 that takes up this angle. Over here on angle XYW, boop, boop, we're going to have 3x plus 10. And so that's over on the other side. And it turns out that we don't have anything about them being the same, so no bisect has been mentioned. We also don't have any like tick marks in here or anything like that, so we don't know if they're the same or what they would do in that case. So instead we have to look to the fact that this down here is a line. And so because this is a line, it has 180 degrees. And so algebraically, we can take the measure of angle WYX, add it to the measure of angle WYZ, and that's going to equal the line, which is angle XYZ. So again, algebraically, that means that 3x plus 10 plus the other angle of 2x minus 5 is going to equal the measurement of 180 degrees. So here's our algebra to practice. I've kind of run out of room, so I'm going to go up here. If I combine the 3x and the 2x, I'm going to have 5x. If I combine the 10 and the negative 5, I'll have 5, and that's going to equal 180 degrees. Take away your 5, and you're left with 5x's equals 175. Or, of course, dividing by 5, we're going to get an x of 35, which, of course, is what the answer key kind of alluded to. Double check every time that you answer or think you have answered a question and see that you actually have, because a lot of times they will want you to plug this x back in, and this one doesn't. It actually just wants you to find the value of x, so we are okay with that. All right, so 35. So that's our example about this. Again, you're trying to just identify this phrase here as you work through each of these problems. So you're saying what plus what or what equals what when it comes to the picture that has been shown. Make sure that as you go through the vocabulary here, you do know or have kind of ideas of what each of these is, how to name an angle, what a vertex is, interiors versus exteriors. Remember that the measure at this point, we're just going to talk about what is given to us, but we will actually use a measuring device very soon on that. A degree comes from 360 within a circle, so just as you're looking for that like 100% of a circle, it would be 360. We have our names of angles as acute, the small one, right, that 90 degrees, obtuse, that's slightly bigger, and then straight angles are going to be 180. And then we also have the congruent angles, so make sure you know that congruence is that shape of an angle that's equal. and then the angle bisector, which cuts it in half. So hopefully that helps, especially now that we have sound. All right.